today we're going to look at how to write some equations here. So the first thing, asking you to do identify the x, y intercepts and the vertex. So our x-intercepts. Where does it cross? Well, it crosses at -1, 0 and at 5, 0. What are our y-intercepts? 0, -5. And then what's that vertex down there? 5, 6, 7, 8, 9. So I think that is 2, -9. So today we're going to look at all the different forms of the quadratic. So some of you might remember there is vertex form. So y equals ax minus h squared plus k. We have intercept form, where we have those parentheses, and then we had standard form. So how do we write this in all three forms? Well, I could write it in intercept form. Y equals our intercepts are -1 and 5, so I know that this has to be +1, and this has to be -5. But then how do we find that a value? We can take any other coordinate and we can plug it in for our x and y. So for example, if I take the y-intercept, I could say -5 equals, and then for that x value, x is 0. And then again, I forgot to write it, but we have that a beforehand. So if I do this, I would have 1 times -5a. So a equals 1. So my final equation would be a equals 1 times x plus 1 times x minus 5. So in vertex form, that a is the same, so it's 1, but I have that vertex. So if our vertex is 2, it would be x minus 2 squared minus 9. And then how we get to standard form, we just have to multiply it out. So if I wanted to multiply it out from vertex form, 1, and you actually don't even have to write the 1. So this is really x minus 2 times x minus 2 minus 9. So if I multiply that out, that x minus 2, got x squared, -2x, -2x, and 4. So this is really x squared minus 4x plus 4 minus 9. So our final answer would be x squared minus 4x minus 5. Now some of you might notice, well, on the graph, I can also find that a if I have another nice good point, and it's just that slope, up 1 over 1 to the next point, so a would be 1. So let's take a look at another one here. Let's first write all these important points. So this is 4, 0, -1, 0, 0, -6, 1, -8. 1, 2, 3, 4, 5, 6, 7, 8. So let's say we want to start with vertex form this time. Y equals a. If it's vertex, this would be x minus 1 squared minus 8. And then let's pick another point. Maybe I want that 0, -6. So -6 equals a, and this x is 0. So -1 squared is 1. So I have -6 equals 1a minus 8 plus 8 plus 8. So we have 2 equals a. So it would be 2 times x minus 1 squared minus 8. How do I see that on the graph? Well, I go up 2 and over 1. So there's one form. So that means intercept form, we have a 2 for our a, and our intercept, so it would be x plus 1 and x minus 4. And then again, we can multiply this out. So if I wanted to multiply out from intercept form, I could take x plus 1, x minus 4. So we have x squared, 1x, negative 4x, and 4. So it's really 2 times x squared minus 3x plus 4. Multiply that out, we have 2x squared minus 6x plus 8. So the last thing we're going to take a look at, here's a quadratic with 3 different forms. So that is all the same. Which one would you use to find the x-intercepts? Well, that's pretty easy. You would use negative x minus 5 and x plus 3. So what does that mean our intercepts are? So our intercepts are the coordinates 5, 0, and negative 3, 0. Which one do you want for the y-intercept? Again, this is the form 0y, where really you could plug any of them in for x, but it's really easy to plug 0 in for x for this one. So we have negative 0 squared, 2 times 0, plus 15. So that's just 15, so our y-intercept is 0, 15. And the min-max, well, that's our vertex form, negative x minus 1 squared plus 16. So our vertex is 1 and 16. And is this a min or a max? Well, I know it's facing down, so this has to be a max. Now, the last thing you've noticed is sometimes our quadratics don't always cross the x-axis twice. Sometimes there's just one solution. And our solution is just where it hits it once. Other times, there's 2 solutions. And then there's what we call imaginary solutions, which we're not going to get into, but I just want you to know when it doesn't cross the x-axis, those solutions are imaginary.